Hello guys, welcome to the Astronaut video where we'll be going through the A-star topics for your GCSE. I hope to go through this as fast as we can, but again I have to remind you this is A-star, so it's going to be a bit intense, so please bear with me. We're going to start with transformations of functions. Okay, and I really urge you to quickly watch. It's only a few minutes, about 8 minutes long video I just recorded earlier today of why each sort of transformation of each graph happens. So I'm hoping, I'm going to assume that we've kind of watched that now, and this is what it looks like in an exam situation. Okay, the curve for the equation y equals f of x is translated, that means just moved along, so that 0, 0 is moved or mapped onto the point 4, 0. So it's just gone from 0, 0 along here. It's not been stretched, it's not been moved up or down, it's just been moved along the x direction. So suddenly we know something's happened inside of our bracket. So it's going to be y equals f of something's happened to x, it's inside of our bracket. It's been moved along plus 4. Remember, inside of our bracket. Okay, if it's happening to x, we have to do the opposite of what we're expecting. So it's going to be x minus 4 inside of our bracket there. And then popping down here, we got this time we got cos. On my video earlier, I just had a look at sine. This is cos now. Y equals cos of x. On the grid, to sketch the graph of y equals 3 cos of 2x. Okay, we know that this stuff here is happening inside my bracket, this 2x, and it's happening against what I'd think. So if it's timesing it by 2, I think it'd be stretching it by 2, but actually it's compressing it by a factor of 2, so it's halving the size of it as we're going along the x direction. So instead of it coming down and up and down and up at that slowly, it's going to happen twice as fast. So instead of it coming down and peaking at 180, it's going to peak at half of that distance, which would be 90, which should be about here. And instead of it peaking at 360 up here, it's going to peak half of it, just 180, it's going to peak up here suddenly. Instead of these troughs and peaks happening every 180 degrees, they're going to be happening every 90 degrees. 90 degrees down, 90 degrees up, 90 degrees down, 90 degrees up, 90 degrees down, 90 degrees up. Great, so I've done my x direction, it's been squashed a little bit. I'm still going to start here at 0, and then suddenly we're outside of my bracket here for this 3, and it's happening how we'd expect. It's stretching our y direction 3 times. Instead of it going to 1, it's actually going to go up to 3. And instead of it coming to minus 1 here, it's going to go to minus 3, up to 3, down to minus 3, up to 3, where's my up to 3, down to minus 3, and then up to 3. And if I just join these together, bring it down and up and down and up and down and up, we should have our graph, a rough sketch of y equals 3 cos of 2x. I'm hoping that it's right for you. Let's pop straight on to the next question. The graph of y equals fx is shown on the grids, this quote here, or they're both the same, but on this grid on the right here it says sketch the graph of y equals f of x minus 3. This is happening inside of our bracket, so it's happening in the x direction, it's being moved, and we know because it's a minus 3, it's actually going to be a positive direction in this way. It's the opposite of what we'd expect for x. So instead of it going through at minus 1 here, it's going to go through at 2, and instead of it going through at 3, it's going to go through at 6. Instead of this little point here, let's move it along 3. Just get as many points as you can moved along 3 to help you get a nice, there's a point there, 1, 2, 3, 1, 2, 3, here we go. To help you get a good idea about roughly where 1, 2, 3 our curve is going to be. And that should give us, if I join that all up, our curve moved along positive direction in the x-axis, but it's a minus there. Great. Part B, on this grid, sketch the graph of y equals a negative x. Now that's something I didn't actually cover in my little video, if we have a negative outside our bracket. Okay, it's something that's happening in our y direction, so it's not going to be moving left or right, it's outside of our bracket, it's something that's completely happening to y. And actually what is happening is our answer, so our original answer, so if I have a look at where x was 0, if x is 0, then my f of x, my answer, is at minus 2. Suddenly that's actually going to be made negative, so negative 2 is actually positive 2. And we actually have the effect of this graph here being just rotated, or reflected, sorry, around our x-axis. That's the effect it has there. If the negative happens inside of our bracket, it has the effect of it being reflected in our y-axis, okay? But we're outside because all of these values here, it was roughly -2.5, it's suddenly going to become plus roughly 2.5. Here it was -2, it's suddenly going to become +2. Here it was 0, it's still going to be 0. That's my 0 is still going to be 0. And all the way up here it was 6, it's suddenly going to become -6. And along here it was 6, it's suddenly going to become -6. So all of a sudden we get this, I've said sudden a lot, I apologise. Okay, we get this upside down curve, and that's kind of the look we're going for, imagining that this is just a mirror, it's just been flipped. And I'm hoping that made a bit of sense for you as well. Let's pop on to our next question. Okay, and we're going to do a few questions now on proofs, because proofs are one of these really difficult questions that we kind of have to go with it. Okay, so this first one here is just a counter example. That's how we disprove this. The sum of two prime numbers is always an even number. He is wrong. Explain why. Okay, the sum of two prime numbers is always even. Well, let me think of a prime number. 5 is a prime number. Plus, sum means plus. Let's think of our prime number 7. That equals 12. That's even. That's fine. I'm fine with that. But can we think of anything, any other prime numbers which won't add to an even number? Let's try 9 and 13. That makes 22. And actually, if you carry on like this, doing a bit of trial and error, you'll go on and you'll find that actually there's no kind of normal primes which add to make anything other than an even number, unless we pick a very special prime number, and that's the first prime number, which is 2. And that's the only even prime number. If you notice, this is odd, and it creates an even number. This is odd, creates an even number. This is even, and any other prime number, let's do 17. That is odd. They will add together, sum together to make 19, which is not even. And if you just write that sentence, not even, give the example, write this sentence, that is not even, so he is wrong. Okay, that's your reasoning, you're going to do that. So that's a counter example. Just play around, do some trial and error, try and find an example which doesn't work. Let's pop on here, prove that. Oh, and this is going to be a lot of algebra right now, okay? Prove that all of this stuff here is a multiple of 4 for all positive integer values of n. Okay, great. Well, all I would say is if you get any sort of question where it gives you some algebra, it's just mess around and simplify that algebra as much as you can. Okay, we've got this expression, 3n plus 1 all squared. Well, let's multiply that all out. 3n plus 1 squared. 3n plus 1 all squared. And the same here. 3n minus 1. 3n minus 1 squared. So it times it by itself. 9n, 3n, 3n, and 1. So that's going to be, oh, that's a 9n squared. 9n squared plus 6n plus 1. Great, we've done that. Let's multiply this out here. 9n squared minus 3n plus 1. Negative times a negative is a positive. So I'm going to end up with this one being 9n squared, take away 6n plus 1. However, I've got this nasty little symbol here, this negative happening in the middle. And I can't just shove a negative here, because all that affects, if I shove a negative in there, all that affects is that 9n squared, when actually up here, that negative affects all of this bracket. So I'm going to have to keep that in a bracket. So let's rewrite this. 9n squared plus 6n plus 1, and let's multiply this negative out. So it's going to be a negative 9 squared. 9n squared, sorry. It's going to be a negative 6n, so it's going to be plus 6n. And it's going to be a negative positive 1, so it's going to be a negative 1. And hopefully we might be able to see that we've got a plus 1 and a minus 1, they're going to go away. We've got a 9n squared, take away 9n squared, that's going to become nothing. We've got a 6n and a 6n. So our final answer is going to be 12n. So all of this faff, and this is why maths is just beautiful, guys, have a look at this. All of this faff here just means 12n. How nice is that? But hold on a second, what's happening with our question? Prove that all of this, so prove that 12n is a multiple of 4. Well, 12 is a multiple of 4 anyway, yeah? Multiple of 4. So any multiple of 12 will also, wills, that's me trying to say will also in the same word, will also be a multiple of 4, and it's kind of this writing sort of statement on that last question. We had to say he is wrong because that is not a prime number. Okay, and here we go, write this sort of sentence. Okay, and I hope that makes sense to you guys. Okay, if 4 always fits into 12, no matter what we times 12 by, 4 is always going to fit into it that same amount of times. So whatever is a multiple of 12 is also going to be a multiple of 4. So that's a kind of proof where it gives you some algebra, and we sort of have to just simplify it and try and make a conclusion from it. And then finally we get the hardest one, I think, where it just says prove using algebra. It doesn't give you the algebra, you have to make up the algebra yourself, that the sum of 2 consecutive whole numbers is always an odd number. And I'll tell you a little truth, or a little confession. Okay, I don't really know when I start a question like this. I don't really know the answer when I've started it. What I do is I just start writing down some random stuff. I just say the sum of 2 consecutive whole numbers. So I just say, well, let's just call a number n, and I write that down, n. And then I look here, the word consecutive, well, that means they're next to each other, and it's a whole number. So the next whole number from n is going to be n plus 1. So right now I'm thinking, right, I've got my n plus 1, I've got my algebra going on here. The sum of 2 consecutive, so it tells me what I need to do to them. I need to add them together. And I have a look here, well, I've got n plus n, well, that's 2 lots of n, plus 1. And it says the sum of 2 consecutive whole numbers. Great, so I've got some algebra now. My 2n plus 1 is the sum of 2 consecutive whole numbers, is always an odd number. That's what we're trying to work out now. It's always an odd number. Well, I'll just have a look at it here. Well, this here, it doesn't matter what n is. 2 times whatever, or 2 times n, is always even. 2 times anything is always even. 2 times 6 is 12, is always even, because we're timesing it by an even number. So if 2 times n is always even, then 2n plus 1, a number that's 1 away from an even number, is always odd. That's kind of our conclusion. And I'm hoping that you have you can sort of see that. If not, let's sort of pause the video, let your mind kind of cool down from being exploded from that. And when you unpause, we're going to continue. Okay. I had to write this question myself. There's not very many past exam questions I could find like this, but it does often happen inside of a bigger question. Make y the subject of, okay, and this is rearranging formula, and this is something that is a kind of B grade or even C grade topic. It's not actually that difficult in concept of rearranging, but we have an A star part of it which is difficult, where it's where we have to factorize within it. Make y the subject of the formula. Well, the thing is, we've got a y here, and we've got a y here, and we've got a y here, and we don't want our y's, the first rule, we don't want our y's on either side. We want to bring them just on one side of our equal sign. So what I'm going to do is I'm going to take this y away from this side, take this y away from this side, and that's going to give me 4xy. Take away, well, I did have take away 3 y's, and now I took away another y, so I'm going to have take away 4y, and that's going to be equal to 3. And now I've got these two terms that I can't bring together, because this is a 4x times y, and this is a minus 4 times y. I can't bring them together because 4x is not a like term to minus 4, that's got an x in it. But what I can do is I can take y out as a common factor there, and you could see, if you were being really, really clever, you could take 4y out as a common factor, but I say there's no point because we want to end up with y on its own anyway. So even if we took 4y out as a common factor now, we're only going to have to divide it all by 4 later, so we might as well just leave it in. So I'm going to take y out as my common factor. What do I times y by to get 4xy? It's going to be 4x. What do I times y by to get minus 4y? That's minus 4. That still equals 3. And now I have my y times by all this faff equals 3. Well, why don't I divide by all that faff? 4x minus 4. Oh, 4x minus 4. Divide it all by that. That's going to leave my y on its own. 3 divided by 4x minus 4. And that is actually what we need to do. We can't simplify that fraction any further, and we've got y on its own. Ka-ching. Next topic. Right, I'm trying to speed up, guys. I'm trying to speed up. I honestly am. Come on, load. Here we go. solve the equation. Now I've got a few questions here on algebraic fractions. This is a kind of simpler solving one. And whenever we're doing adding or subtracting fractions, our normal method is kind of an upside down picnic table, where we're going to end up with a big fraction. It's got a minus in the middle of it, so that minus is going to go here, and it is going to equal 1 in total. Let's keep that the same. Now following my picnic table, in my top left here, I've got an x, and the arrow goes down to x plus 1. So that's going to be x lots of x plus 1. My top right hand is going to be top right, which has an arrow down to 2 times 2, which is 4. And then along my bottom, I'm going to have my 2 lots of x plus 1. 2 lots of x plus 1. Great, and I need to simplify that down a little bit. And in order to do that, I'm going to have to multiply this out so that that minus 4 can get stuck in. So that's going to be x squared plus x minus 4 over 2 lots of x plus 1, and that all equals 1. And now what I might initially try and do is I might think about factorising this. Is there anything that I know that multiplies to make a minus 4 and adds to make a plus 1? I can't think of anything on top of my head, so no, we're not going to be able to factorise it. It's not going to be that nice and easy, okay? Because sometimes with our algebraic fractions, we end up factorising this, and one of the brackets is this x plus 1, so automatically it crosses out. No, this is a little bit harder. We have to think about this stuff here divided by this stuff here is equal to 1. Well, the only way I'm going to get something divided by something to equal 1 is if that something, so my x squared plus x minus 4, is equal to the stuff on the bottom, 2x plus 1. That's the only way that's going to work. Something divided by something is 1, so that must equal that. Great, let's rearrange this so I've got all my x's on one side of my equation. In fact, I might multiply that out quickly so it's a little bit simpler. 2x plus 2. I think I only just factorised that a bit, didn't I? No, I didn't, no. Right, I've got my 2x plus 2, so I need to get rid of my 2x. I'm going to take away 2x, and I'm going to take away my 2. So it's going to be x squared, take away x, because I've got my x, take away that 2x. And I've got my minus 4, take away my 2, so it's going to be minus 6, and it's going to leave me with nothing on the side here. Minus 2x, and I'm going to minus 2. That's my little thing I was doing in between. And now I have a little quadratic equation to solve here. Okay. And I'm just going to try and factorise it. Two numbers that multiply to give me a minus 6 and add to give me a minus 1. Well, I'm thinking straight away x equals, okay, it's going to have to be a minus 3 and a plus 2. That's what I'm thinking right now. Because minus 3 times 2 is minus 6, minus 3 add 2 is still minus 1, great, and that equals 0. And we get this little statement happening down here. I'm just going to bring this up around here because I'm running out of a bit of space on my board right now. X minus 3 times by x plus 2 equals 0. Well, anything times anything, if it equals 0, that means that either this equals 0, in which case my x plus 2 equals 0, so x must be minus 2, ka-ching, that's one answer, or this equals 0, which would mean my x minus 3 equals 0, which means x equals 3. And they're my two answers for that. That's solving a quadratic for you. So there we have it, that's solving a algebraic fraction, and I said that was an easy one, and I was being dead serious because we get a slightly trickier one coming up along here. Solve this bad boy, and it's the same concept, something equals 1. We do upside down picnic table. So what I'd like you to do, I'd like you just to pause the video and just do that initial step. I don't want you to finish the whole question, just do the initial step, so you're not just sat there just watching me just waffling and waffling. Have a go at just doing the KFC to that, so we're going to end up with a big fraction, it's got a plus in the middle, equals 1. Okay, pause the video now. Okay, welcome back, and you should have hopefully have ended up with 4 lots of 2x minus 1 and 3 lots of x plus 3 divided by x plus 3, 2x minus 1. Great, and we want to multiply that out and simplify that, which is going to give me 8x minus 4 plus 3x plus 9 divided by, and I'll multiply the bottom out as well because I think I see where this question's going, 2x squared x times minus 1 is minus x, x times 3, so it's plus 5x minus 3, and that equals 1. And again, bring this together, sorry, before I say it again, that's 11x plus 5 over 2x squared plus 5x minus 3 equals 1. And again, we have the same property going on here. Something divided by something is 1. So it means this something on the bottom, our 2x squared plus 5x minus 3 must be equal to whatever's on the top, 11x plus 5. And if I rearrange that, if I take away 11x and I take away my 5 to make that 0, I'm going to end up with 2x squared minus 6x and take away 8. And I need to factorise that bad boy. And this is going to be a slightly hard one because we're factorising, if you notice this number, if I notice on the previous question here, our quadratic we had to factorise just had an x squared on its own, which means we can shove it straight into brackets. Now we've got a 2x squared, makes it a little bit harder. I'm going to change to a red pen because it's marking that occasion. 2x squared minus 6x minus 8 equals 0. And my tip for multiplying out this is kind of practicing our algebraic fractions and practicing our factorising and solving quadratics at the same time. It's a double whammy of an A-star topic. What I always say for these ones is times your a by your c. So ax squared minus bx, ax squared plus bx plus c equals 0. That's sort of normal form of quadratic times these two. That arrow is not quite pointing at it. Times those two together. So 2 times minus 8 is minus 16. Great, so I've got my minus 16. And now instead of trying to find, like in the previous ones, we're trying to find two numbers that add to make this middle number and times to make this end number. Same principle, but they've got to add to make this middle number, which is minus 6. Why am I trying to put minus 6x? Just minus 6. We need to find two numbers that add to make this minus 6. And they're multiplying. They're not multiplying to make the minus 8 now, they're multiplying to make this minus 16 now. And we can play around with our numbers a little bit, but in my head I'm thinking 8 and 2. 8 and 2 make 16, and if I did 2 and then took away 8, I'm going to end up with my minus 16. So I'm thinking it's going to be a plus 2 and a minus 8. That's the two numbers I'm thinking. So, and then we just rewrite our equation out. 2x squared and our minus 8 equals 0. And the reason why we've done this is we wanted to split this minus 6 up into two numbers that it would have been when we expanded it. And we're going to put it into the grid and work backwards to factorise it from there. And that will make sense in a second. Okay, so my two numbers are plus 2. So I've got a plus 2x and a minus 8x. And this is what I would have had when I expanded my brackets using the grid method. I would have had a 2x squared plus a 2x minus an 8x minus an 8. I would have brought that together to give me my minus 6x. So let's put that in the grid. 2x squared, 2x minus 8x minus 8. And that is in my grid from multiplying out my two brackets. And this is going to help me work out what my two brackets are. Well, the highest thing that goes into 2x squared and minus 8x is a 2x. And the highest thing that goes sorry, not the highest thing anymore. I'm thinking, what times 2x makes 2x squared? Well, it's just x. What times x makes 2x? 2. And finally, what times 2 to make minus 8? Minus 4. And this is a really good method, working backwards from my grid, because it also self-checks for us. X times 2x is 2x squared. X times 2 is 2x. Minus 4 times 2x is minus 8x. And minus 4 times 2 is minus 8. Great, so I end up with my two brackets, x minus 4 and 2x plus 2 equals 0. And again, each of these brackets is going to give me a green pen. There we go. Each one of these brackets is going to equal 0. So x minus 4 equals 0. So x must be 4. And I have 2x plus 3 equals 0. So x must be minus 3. What is happening to my pen? X equals minus 3 over 2. There are two answers there. And that's a beast of a question. This is question 29. This is like the last question on the paper pretty much. I would guess it's worth about 5 marks at the very least, I must say, because we've got to do some algebraic fraction simplifying over here, and then we've got to factorise a quadratic that has a non-unitary coefficient of x squared. That's the posh word for that. So that's a beast of a factorisation you've had to do, and then solving it, two different answers. yeah, that's a beast of a question. I'm hoping that you managed to follow some of that. Pause, rewind, watch it again maybe. And finally, our algebraic fractions can be just a simplified question, and that just requires us to factorize. So I'm going to factorize the top of this straight away because it's just an x squared on its own. So it's going to be an x and an x, and it's going to be two numbers that multiply to make my 15 and add to make minus 8, and that must be 3 and 5. It's a minus in the middle and it's a plus here, which means both my numbers must be minus. X minus, and I'm thinking minus 3, minus 5, yeah. Minus 3 and minus 5. And that's going to go over my fraction. And I'm going to work out what this is. And actually, this would be a good chance for you to have a practice. You need to factorize 2x squared minus 7x minus 15. So I'd like to have a go at factorizing that. Remember, we do our a times our c, which is going to give me minus 30. And I'm thinking of two numbers that need to times to make minus 30 and need to add to make minus 7. So pause video a second, why don't you have a little go at factorising that. Okay, welcome back. I hope you managed that. That would be fantastic if you did. I'm just going to put my 2x squared and my minus 15 down here. Now, two numbers that multiply to make minus 30 and add to make minus 7. Now, I had difficulty thinking up this. I'm just thinking minus 30, well that's either going to be 1 and minus 10, not minus 10, 1 and minus 30, sorry, 2 and minus 15, not going to work, and 3 and minus 10, that's going to be, isn't it, because 3 minus 10 is our minus 7, 3 and minus 10, perfect, they're the numbers I'm thinking. So 2x plus 3x, 2x squared plus 3x minus 10x is going to be my expression written out there, and if I put that into my grid, 2x squared plus 3x minus 10x minus 15, and get them a different colour pen, and then work backwards. This should have given us 2x and an x, a plus 3 and a minus 5, and let me just check, minus 5 times plus 3 is minus 15. Great, it all works out. So I know that on the bottom of my fraction then, let's go back to my horrible colour green, I don't know where I got that colour green from, my two brackets are going to be 2x plus 3 and x take away 5. Hold on a second, they're all being times together, I've got an x take away 5 on the top, and I've got an x take away 5 on the bottom, which is going to leave me with just x minus 3 divided by 2x plus 3, and that is my final answer. I can't simplify that any further. Great, and I think I've got one more kind of fraction-y kind of one going on. Ish. Okay, factorise this bad boy here. This is just how we normally factorise, nothing in front of the x. I need to find two numbers that add to make rp and rq and times together to make pq. Well, this is literally just the algebra behind how we just normally factorise. X plus p, x plus q. That should be right. And here we've got a square number here. Notice this 4 is a square number. So we know that this is going to be the difference of two squares, and immediately that's just an m plus the square root of what that 4 is, which is 2, and an m minus whatever the square root of that 4 would be. Great, and you can always multiply that out to check you've got that right. And then finally, just writing some fractions in the simplest form is going to be doing our upside down picnic table to them. So why don't you actually have a go at writing that fraction in its simplest form using our KFC. We're going to have our big fraction with a minus in the middle. Have a go at that, give it a pause. Okay, welcome back. I'm hoping that you would have ended up with two lots of x plus 3 and one lot of x minus 4. With a minus in between them, and then on the bottom we're going to have an x minus 4, x plus 3. I need to simplify this all out now. I expand this bracket, 2x plus 6 minus x plus 4. Remember, this minus here affects that x and that minus 4. Divided by x minus 4, x plus 3. I'm keeping the bottom factorised because I'm thinking it says in its simplest form there's going to be some sort of cancelling out going down, and that's only going to come from factorising. Let me just rearrange. So I've got my x minus 4, and my x plus 3 in the bottom, and let's simplify this top to gather the like terms together. So I'm going to have an x on its own, and I've got a plus 6, and I've got a plus 4, x plus 10. And in actual fact, that doesn't actually cancel out of anything. So as far as I'm concerned, that's in its simplest form. I was hoping to get like an x minus 4 and x plus 3 so it cancel out something on the bottom, but it doesn't. I'm just double checking I did that right. I did that right. Yeah, definitely well prepared for this video. Okay, that's its simplest form as far as I'm concerned. Right, moving on. When it's ready, here we go. Completing the square. Okay, that's a really awkward topic of factorising our quadratics, and we do end up, again, this is the algebra behind the form. We end up with an x plus something all squared, and we have that left over as a q. And I'll let you into a little secret. Okay, when we do our multiplication, we have like an x plus a, say, and we all square it. If you think about our grid, x plus an a, x plus an a, I end up with an x squared. And then I get an ax there, and I'm going to get an ax here. It doesn't really matter what it's going to be if that's an a squared. But I want to focus on these ax's. I've got two lots of them, haven't I? Oh, that's supposed to be blue. Why have you green? I've got two lots of my ax's. Two lots of ax. And my final answer gives me two lots of my x. So this bit here is like is two lots of what's in the middle. So cutting to the chase, Mr. Osman. Come on, get to it. Okay. When you go into your bracket, I just half that 6 to get that number inside there. That's what I always do. I just do right x plus 3 and all square it because it's a 6 there, because when I multiply this out I'm going to have my 3x and my 3x. If I call that a 3 and that a 3, that's going to be a 3 there and a 9. Okay. When I add these two together, that's going to be 6 x's, which is what I had in the middle. So just half that number in the middle, and that's 6, and that's going to be what goes in here. X plus 3 all squared. And actually we did just multiply that out here. Do that multiplication, multiply it out, and we're going to end up with x squared plus 6x plus 9. And that's what we end up with if we just left it as x plus 3 all squared. However, we know it's not x squared plus 6x plus 9, it's actually x squared plus 6x minus 2. And so you need to compare the difference between that 9 and that minus 2. What the difference is to get from there to there, and so I just realised I put loads of arrows on this page. I'm hoping you're following this. To get from that 9 to that minus 2, I need to take away 11. So my final answer is going to be this x plus 3 all squared, which is great, that gives me this, but actually in order to get what I originally had, I need to take away 11 on the outside. And obviously the question says find the value of p and the value of q. So p equals 3, q equals minus 11. Let's move on. The diagram shows a solid hemisphere of radius 8 centimeters, and I'm just turning around to pick up my calculator ready for this because I've just realised we're talking pi suddenly. If you flick to the front of your formula book in your exam, you'll notice there's a formula which is the surface area of a sphere. It gives you a formula for that in your formula book, and that is 4 pi r squared. And that's for a sphere. We've got a hemisphere, so in this case we only want half of our 4 pi r squared, and my radius is 8, so I'm going to do a half times 4 times pi times 8 squared. And then my calculator, let's pop this down, half 0.5 times 4 times pi times 8 squared. Pop it in my calculator, I get 128 pi. I'm not going to write it as a decimal just yet because I'm not quite finished. Okay. The total surface area, well, all I've worked out is the surface area of half of a sphere, which is going to be this stuff here. I've not worked out the surface area of the circle, so I'm going to have to plus onto that the area of a circle, which is pi r squared. Sounds like area to me, blah blah blah. If I need a circumference, I'll use pi d. etc. plus pi r squared is what we're going to need to do. So that's going to be pi times 8 squared, which is going to be 64 pi. So I've got my 128 pi plus 64 pi, which is going to give me 192 pi. And if I multiply that out times pi as a decimal, write out all the values in my calculator, 603.1857895, and it's asked me to do it to 3 significant figures. So I'm going to go 1 significant figure, 2 significant figure, 3. It's going to go there, so I'm going to cut off just after it. Is it going to stay at 3 or go up to 4? So 1 there, so it's going to stay as a 3, 603. And are we talking any units? Here we are, we're in centimetres, and this is an area, so this is centimetres squared. Next question, please. I'm like a question jukebox this afternoon. The diagram shows a cone. The radius of the base of the cone is 10 centimetres. The slant height of the cone is 15. Now you need to think to yourselves, there's a big difference between the slant height and the perpendicular height. Okay, in this equation here, when we're trying to find the volume of the cone, we need the perpendicular height. But in our surface area, we need the slanted height. So there's a slight difference going on there. Work out total surface area of the cone, give your answer as a multiple of pi. Great, surface area. I'm talking about a slanted site. So that's going to be surface area equals pi times the radius times the slanted height. Well, it says L. Slanted height. That's going to be pi times my radius, which is 10, times my slant, which is 15. So that's going to be 150 pi centimetres squared. Okay, don't forget surface area, we're talking centimetres, it's going to be centimetres squared, don't forget that. A second cone has a surface area which is 64 times the surface area of the cone in part A. Work out the radius of that. We don't go divide it by 64. There's a difference here when we're talking about measures. Okay, if we're going from a length to a length, okay, that's just timesing. If we just that's just the timesing, that's fine. Let's say if I got 4 times bigger, I've got a length, so I times it by 4. It's going to give me another length, okay? But if I'm going to go from a surface area, or an area of something, to the surface area of that same shape as times by 4, I can't just times by 4, I have to times it by 4 squared, because it's area. And if it's a volume of something, and I'm going to the volume of something, I have to times it by 4 cubed. I've just chosen 4 arbitrarily. And we have this case here. We've gone surface area to my new surface area, and I've times it by 64. So in order to do it for length, I need to work out what the square root of 64 is. Well, the square root of 64 is 8. So it's actually only timesing it by 8 to get from this cone to get to our new cone. Work out the radius of the base in the second cone. So I'm just going to have to do 10 times 8, which equals 80 centimetres. Don't forget units. I'm hoping this is a little bit coherent here. Just for converting measures. And in proportion, that's what goes down there. And that's a difficult concept. Basically, if you're enlarging a shape, the sides of that shape increased. If I'm enlarging a shape by 2, the sides of it do enlarge by 2 times. But if the area of it actually enlarges by 2 squared, and the volume of it, if it is a 3D shape, actually enlarges by 2 cubed, suddenly it gets a lot bigger and a bit out of hand. Let's move on then. I've got one more question, I think, on cones. The diagram shows a solid cone and a solid hemisphere. The cone has a base of radius x and a height of h. The hemisphere has a base of radius x, and the surface area of the cone is equal to the surface area of the hemisphere. So let's remember our surface area of our hemisphere, or surface area of a sphere. Surface area of the hemisphere, that was pi r squared. It's 4 pi r squared plus an extra pi r squared for the circle, for the surface area, wasn't it? Pi r squared, not pi squared. And the surface area of the cone, well, we've got a formula for that here. Curved surface area and surface area of the cone is going to be our pi r squared. It's a circle, don't forget the circular base. Pi r squared circular base plus the surface area of that curved bit on our, actually thinking about that, pop it back. Oh, I did do that, didn't I? Great, Mr. Osmond's a numpty. The curved surface area of the cone just gives me this curved bit, it ignores that circle at the bottom, and that's what I've done here. I've completely ignored the circle. I've completely ignored the circle, so actually my 150 pi is just the curved bit. I have to, and then add on pi r squared. Oh, I'm such a numpty, I can't believe I forgot that. Okay, so even genius mathematicians make mistakes. My radius is 10, my radius squared is going to be 100, so I'm adding on 100 pi, so it's going to be 250 pi centimeters squared. I can't believe I forgot that. Okay. Ooh. So I'm going to have, let me just go back and get my formula for it actually. Pi times r times l. Pi times r times l plus that faff there, the circle on the bottom. Find an expression for h in terms of x. And this is actually a really awkward question because our h is our perpendicular height. H is perpendicular height, where however our formula we've got here doesn't have h involved at all. But we do have, if you picture here, we do have a right-angled triangle. Where this is x, and this is L, and this is h. And we know that our L squared is going to be equal to h squared plus x squared from our Pythagoras. So our h squared is going to equal L squared take away x squared. That's what, and so h is going to equal the square root of L squared take away x squared, which is fine, but we don't know what L is, which isn't very nice. Which means we're going to have to use all this expression-y stuff here to help us work out what x and L are, or it's going to help us work out what L is. So let's get all this stuff written down. This is a really complicated question. Okay, pi times r times L plus pi r squared equals 4 pi r squared plus another pi r squared, so actually it's 5 pi r squared. So we've got 4 of them plus another one, equals 5 pi r squared. Now I need to replace my r's with x's, don't I? So it's going to be pi times x times L plus pi x squared equals 5 pi x squared. Whoa! And I'm going to get all of my x's onto this side. I want to get L on its own. I want to get an equation including L on its own. So I'm going to get, I want to leave L on its own, so I'm going to take away this pi x squared, take away pi x squared, which is going to give me pi x L equals only 4 pi x squareds left now. And I'm going to divide by my pi, divide by pi, which is going to give me xl equals 4x squared, because I've cancelled out my pi there, and I'm going to divide by x. Actually, it's starting to look a lot nicer than I thought it was going to. L equals 4x, and that's my little statement there. I found out what L is in terms of x, and if I shove that all the way back and into my equation for h, okay, I'm going to get myself h is equal to square root of 4x squared, don't forget all of that is squared, take away x squared. So h is going to equal the square root of 16x squared, take away x squared, So h is going to equal the square root of 15 lots of x squared, and that is going to be your final answer. So essentially the hardest thing to recognise there is actually our surface area is calculated in our L, and we didn't know what L was, so we had to recognise some 3D Pythagoras in here to come out with this equation here, and then multiplying all of this out was just to get L on its own, and that got quite complicated, but then it simplified very easily, and that was beautiful. I don't think there's too long left, guys, hanging in there. I think this is actually the last question. Let me skip another slide. Last question, great. Whew. V is equal to the square root of a divided by b. A is 6.43 to correct 2 decimal places. B is 5.514 correct 3 decimal places. By considering bounds, work out the value of v to a suitable degree of accuracy. And now what I want to think about here is I want to think about what the smallest value v could be and what the maximum value v could be, and take an average of the two. And that's quite a long question, but again, question 28 is one of the last questions on an exam. You're going to have to do some work for it, so it's going to be worth a lot of marks. So first of all, I need to work out what my A maximum is, because my A max, because A's been rounded, and I want my A minimum. And with bounds, the whole rounding up or down at 5 kind of doesn't matter. So the maximum A could have been is 6.435. I know that normally in numbers that would round up to 6.44, but with bounds we say it's 0.5 above, or 0.005 here, and the minimum it could have been is 6.425 if we go down the next place, because that would round up to 6.43. That's my A minimum, A max. Let's do the same thing for my B. My B minimum and my B max is going to be 5. My minimum is going to be 5.5135, and my maximum is going to be 5.5145. Okay, great. And so my Vmax, this is where the big boy comes in here, my Vmax is going to be when this fraction is at its maximum. So when it's at its maximum, it's going to be when A is as big as it possibly can be, and B is as small as it possibly can be. So I'm going to need my A max, square root of A max, over B minimum. And to get my smallest value of V, I'm going to need to get when this fraction is at its smallest, and that's when my A is the smallest it possibly can be, and B is the biggest it possibly can be. So I'm going to have my A minimum and my B maximum. And the reason for that is if I've got a small amount of a large, if I get my cake and I cut my cake into a certain amount of parts, that's what the denominator is. So the more parts I cut my cake in, the smaller each piece of cake is, and A is how many pieces of cake I get. So if I cut my cake into 10 pieces, they're quite small, and I only got one piece of those 10. That makes it very, very small. Whereas if I want to make this fraction big, I might cut my cake just into 2 pieces. They're massive, 2 massive pieces, and I want as many pieces of those 2 pieces as I can do. Suddenly those pieces get bigger. My fraction gets bigger. Okay, great. So my Vmax and V minimum, and what you just need to do is just plug in my values and calculate them. And if I was you, I'd try and keep it all in one line in your calculator. And I know what I'm going to be doing with this. I'm going to be finding an average. So I want to be doing my Vmax plus my V minimum divided by 2. And I'd love for you to actually have a little go at writing this all out on your calculator. So all on one calculator display, you're going to do the square root of my A maximum, 6.435, divided by my B minimum, which is 5.5135, plus the square root of my A minimum, which is 6.425, divided by my B maximum, which is 5.5145. All of that divided by 2, all in one big calculator display in one go. So let's have a go at that. Okay, I'm gonna see. Let's have a little race. I've got my calculator in front of me. Let's have a go at this. 6.435. 5 plus, if you're watching the video, just fast forward if you want to know the answer, 6.425 over 5.514. Let me just double check I got all of those numbers right. Yeah, 5145, sorry. Okay, and that's all divided by... Oh no, I put all of my square root. Oh, that's awkward. I have to delete all those last numbers. Right. Come out of your square root and then hit your plus. Make sure you're still on top of your fraction, then hit your new square root for your next one. That's where I went wrong. 6.425 divided by 5.5145, and then all of that is divided by 2 plus equals, oh, I finally got there, 1.079871506. Great. And then it says, to a suitable degree of accuracy. Now I'm thinking, where should I round this to? And I'm thinking, right, you know what? This is rounded to 2 decimal places, this is rounded to 3 decimal places. 3 decimal places is more accurate, it's taken it accurately to more, to a much, I can't think of another word for accurate. I'm repeating accurate a lot. It's been a long video, please bear with me. We're at the end. I'm thinking 3 is more accurate, 2 is the least accurate thing, and because 2 is the least accurate thing in there, I'm going to stick with 2. So I'm going to call it to 2 decimal places. So it's going to be arrow in at my second decimal place, cut off after it, it's a 9 after it, so it's going to go up to an 8, so it's going to be 1.08 to 2 decimal places, because that was the least strict rounding to start with. Okay, that's the least strict rounding to start with 2 decimal places, and whew, oh, we made it through the video, guys. This A-star topics are quite difficult. I really hope that you managed to follow some of these. Just so that we can have a little bit of nostalgia in us. Let's have a little flick through what we've been through together. Back along there, look at all of that, look at 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 that. Oh, those quadratic, those factorising those quads were a bit tricky, weren't they? Make y the subject, nice and easy. Doing some proofs, oh, that seems yonks ago. Keep going back, our transformations of functions. And guys, there we go. I hope this is useful to you, and very best of luck as you continue to revise and in your exam. Well done. Signing off now, Mr. Osmond. Bye bye.